In this video, we will talk about working with remote servers, which is generally what we do when we try to run computation and memory intensive algorithms. Since our desktop computers generally don't provide us the necessary resources, it's very likely that you will need to work with a remote server at some point. We can connect to a remote server using a dedicated protocol called SSH from the command line. The name SSH is an abbreviation of Secure Shell. As an example, we will try to connect to the Puhti server of CSC Finland. By now, you may have already gotten a username from CSC. If you didn't, first register through the website mycsc.fi for a username, and then please contact us for gaining access to the Puhti server on which you can try these commands. In the most simple case, you can connect to a server using the SSH command followed by the server name. This will ask for the password in the server, and our connection has been accepted. Now we are running a bash program in the remote server. You will typically see a new prompt here, which is the prompt that the bash program in the remote server provides you. From this point on, the commands that we give here, they are working in this Puhti server, Puhti computer. So the contents that we see using the ls command are my files in the Puhti server. When we are done working with the remote server, we can quit this prompt to return to our local computer. For quitting, as usual, you can use the command quit, or you can use the shortcut Ctrl+D. This is going to kill the current bash program, and we will fall back to our local computer. We can also make an SSH connection using some specific settings. In particular, if your username, so my username is Chilikan in my local computer, say if my username in the Puhti server was different, I would need to specify this different username for connecting to the server. In that case, you can give the username with this kind of syntax, username at the name of the server that you want to connect to. I will cancel this connection. Another setting that you may need to specify is the port number. SSH connections are by default done over the TCP port number 22. However, your server might have been configured to listen for incoming connections from a different port for security reasons, usually. In that case, you would need to denote the correct port using the parameter -p and then say my username and the name of the server. It may be necessary that you need to specify these informations, and you may not want to do it every time. So instead of specifying these with every command, we can just put them in a configuration file. The configuration files are used very commonly in Linux. We will see our first example here in SSH, but we will also be seeing more examples of these config files as the course progresses. The config files typically need to be put in some specific locations where the program is going to go and check. Typically, they can either be under your home directory, in which case they will be valid for only your own user, or they can be in a system level directory, and then they will be valid for all the users in the system. For now, we will use the option of putting the configuration file into our home directory, since first of all this is more commonly done, and also for now we don't know how we can become a super user and manipulate the system level files. The user's configuration file for SSH is located under the user's home directory under a folder called .ssh. Files and folders that start with a dot are hidden files and folders. They are generally used either for configuration files or to store some program-dependent data. A normal ls command doesn't show them, but we can see them using the -a parameter. As you can see, I myself have a number of hidden files. For example, the .bashrc file you see here is the config file for our bash program, We will see this file in detail in the forthcoming lectures. Similarly, .emacs is the configuration file for the Emacs editor, and .vimrc is the configuration file for the Vim editor that I use myself. In here, I already have a .ssh folder, so I don't need to create a new one. But in case you haven't used the ssh command yet, you may not have one by default. In that case, please create a .ssh folder by yourself using the command mkdir.ssh. Once you run this command and you have an SSH directory, let's go into this directory and see what is there already using the ls command. So this shows the known hosts file, which is created by SSH when we try to connect to a server for the first time. Now here we will create a config file for SSH. For this, we will use the Emacs editor to open up a file called config. This will be our configuration file. It will start as an empty file. We should obey a specific format. For example, let's write a configuration for the PuTTY host. We start by creating a division with the keyword host and giving the alias that we are going to use to connect to this host. Then an enter and a tab. We will write the full host name here. We will write the user that we are going to use, and we will write the port that we are going to use for this connection. We can continue adding other servers. So now I will save this file and I will exit with a Ctrl X and a Ctrl S, then a Ctrl X and a Ctrl C for exiting. Now if I say, for example, if I go to my home directory and if I say ssh PuTTY, this is going to read from the file that my username is going to be Chelikan and the exact name of the server is going to be PuTTY CSV and the port is 22, and then I can write again my password and connect as I did before. Now let's talk about copying files between two computers. For this we use the SCP command, which is short for Secure Copy Protocol. The SCP command allows us to copy files over SSH connections. For example, you may generate some result plots in a server and then you may want to view them in your computer, and in that case SCP will come in handy. The format for SCP is like this. So SCP username 1 at server 1 semicolon, then path to the first file, and then username 2 at server 2 at the file at path 2. As a general rule, file commands in Unix use their first argument as the source path and the second argument as the target path. So say we want to copy a file from our local computer to a remote computer. In that case, our local file will be the source and the path in the remote server will be the target. So let's say we want to copy the life of B file from this path to PuTTY. We first denote the source of this transfer as the first argument. Note that if we are talking about a local computer, we can omit the username and the host name because it already knows. Then we say, for example, we want to transfer this file to PuTTY, and in PuTTY I want to put this file to my home directory, tilde being the short form for our home directory. And the file has been transferred successfully to the PuTTY server. On the other hand, if you want to bring a copy from a remote server to our local computer, then first we start with the remote server. This will be our source this time, and say I want to bring from PuTTY the file life of b.txt here to my current directory. I will use a dot as the shorthand for my current directory. Then the first is my source and the second path, local, is my target. The transfer is complete. If I make an ls now, I should be able to see this file in my local. You can also copy entire directories with SCP. And for this you must use the dash R flag like you have been using with the normal copy command when you are talking about directories. So say I want to copy this entire directory Topuhti to my home, then I can only do this using the -R flag. This moves the folder and everything inside it to Topuhti. If I didn't use the -R flag, then I would have received the error that this is not a regular file, meaning it's a folder and it requires the -R to be able to transfer it. That's it for this video. See you in the next videos.